So hi everyone, I'm Lauren Vasey. I'm a research associate at the Institute for Computational Design, the ICD, at Uni Stuttgart.
And my name is Maria. I'm a student at IDEC program in Uni Stuttgart.
And we're going to present our project, which is about really embedding sensors in materials and getting live real-time feedback about material systems. So at the ICD with the ITKE, we have a kind of master's program for new technologies in architecture called the iTech Master's Program. Every year we do these kind of very experimental research pavilions, which might be using new technologies in fabrication, such as robotic fabrication, material systems, and simulation technologies. And this year we're doing a collaboration with a kind of composite production institute called IPFT. And the kind of idea for this pavilion is that you have actually robotic architecture. So we're combining new fabrication techniques and variable and kind of laminating composites, which gives us a very specific ability to build up materials with kind of robotic or machinic actuation. So one aspect of what we're trying to develop is really looking at how we can embed sensors in our kind of large-scale deforming, actively changing structure to get meaningful information about its behavior, about its structural condition, to make sure it's also working correctly.
And so the kind of sensors that we were using are called strain gauges. And with those, we're able to get the strain values of a moving object. And when we arrange those strain gauges in this kind of a full Wheatstone bridge configuration, this allows us to have a very precise measurement of this sort of movement, of the character of this movement and its amount. So this is sort of how it looks on a physical prototype. And note that we were placing our sensors very strategically in the areas that have most curvature. This is one of our hardware setups, basically. So our sensors are being connected to a node that has integrated amplifier, Wheatstone bridge, and Wi-Fi transmitter. Then it transmits the sensor data to the Wi-Fi base that is then connected to a computer. If you want to add something.
So we're kind of partnering with a company that's a sensor company in the US, and they're making kind of wireless node networks, and they're called LORD. And so there's two kind of ways to get meaningful sensors. There's Sensor Connect, which is their custom program, and there's also an API, which allows us to access the data. We're also trying, this is a higher cost solution, and then we're trying to do at the same time a low cost solution, which is using the Arduino and an amplifier connected to the same setup of Wheatstone bridges. So this is a video that we recorded here, and you can see this is using Sensor Connect, so you can see when you bend it up, you can see directly that it's bent up and then it's stabilized in a condition. This is the data, for example, if you're shaking it. This is when you're just bending it, it looks somewhat linear. We can also export this as a kind of CSV file. What we're interested in doing is recording different types of motion and then looking at the way the data is changing and kind of corresponding this to kind of event-based detection. So we're saying, is it windy? Can we detect that from strain gauges? Is someone shaking it? Could we detect that also from kind of event-based methods? We're also thinking about geometrically reconstructing the data. So this is just linear interpolation, where you know the strain that you would, or the strain at the kind of flat bending state and the strain in the one curvature, and then you can linearly interpolate. And we also are going to kind of link that as well to dynamic relaxation to kind of begin to understand if we're getting into forms outside of what we would expect in our system. So we were successful in somewhat getting live sensor feedback, but I think what we really need to do now is do kind of more really meaningful analytical methods. And the idea is that we're going to kind of embed it on the whole structure, so we'll probably have about 10 of these node locations and stream the data in real time and try to make meaningful determinations about what is happening. So that's it.